Hello everyone. In this video, we are going to solve question number 1 of GATE 2010 paper. The question is from tensor analysis. So the question is, consider an antisymmetric tensor Pij with the indices I and j running from 1 to 5. The number of independent components of the tensor is. So we have been given a 2-rank tensor Pij and it is antisymmetric. Antisymmetric means Pij is equal to minus Pji. That is, for an example, your P12 will be nothing but P21. So these two quantities are not independent. So if you know P12, then you can determine what P21 is. So hence these two quantities are independent of each other. So the degree of freedom associated with these two are only 1. Okay. Similarly, your P23 will be equal to minus P32 and so. And by the virtue of this property, if we suppose we have diagonal elements, for diagonal elements, your indices I will be equal to j. Therefore, your Pii is equal to minus Pii if we just put j is equal to y in this equation. So 2 Pii is equal to 0. So your diagonal elements of this antisymmetric tensor is 0. So using this property, you can just easily find out what is the number of independent component of the tensor. So okay, let us write on. So since I is running from 1 to 5, so let us do it manually. So first component is what? P11, but P11 is 0, so we will ignore it. What will have P12, P13, P14, P15. These are the combinations. Now let us take P21. Now P21 is not independent because P21 is P12, so we'll ignore P21. P22 is 0, so what we left is P23, P24, P25. Similarly, P31 will be equal to P13, so we'll ignore it. P32 will be equal to P23 minus of P23, so we ignore it. P33 is 0, so we'll left with P34 and P35. Similarly, we'll left with P45. Okay, so and with P51 is equal to P15, P52 P25, P35 P53. Okay, so all the other combinations are not possible. So we have only these number of independent combinations or components of a tensor. So total number is 4 plus 3 plus 2 plus 1, so 10. So there are total 10 number of independent components of this antisymmetric tensor. So you can easily find it manually. Now there is another shortcut way through which you can find out. So number of independent components of a tensor is nothing but half of n squared minus n, where n is a total number of indices. So your total number of indices is 5, 1, 2, 3, 4, 5. So it will become 5 square 25 minus 5, which is 20 by 2, which is 10. Okay, so directly with formula also you can find easily, but if you don't remember the formula, then also you can easily find it manually using this process. So B is the correct answer for this option. Thank you for watching this video.